looked around and just noticed that some of the most amazing things we've built, say a giant bridge or an instrument that can listen to the stars, they seem to share a secret divine? Well, you're not wrong, they do. And today, we're gonna crack that code together. Okay, so picture a satellite dish. It's got that very specific curve, right? That shape isn't an accident. It's perfectly designed to catch a super faint signal from thousands of miles up in space and focus it so you can watch TV. But how does it, know how to do that? Now, let's switch gears. Think about one of those old, beautiful stone arch bridges. They can hold up unbelievable amounts of weight, and they've been standing for centuries. That curve isn't just for looks. It's a very particular shape that magically pushes all that force safely down to the ground. And here's where it gets really weird. What on earth could a satellite dish and a stone bridge have in common with how a planet orbits the sun? I mean, one's tech, one's engineering, and the other is just pure astronomy. They seem totally unrelated. Well, the answer is that they're all using the same hidden code. It's a secret that's been hiding in plain sight for thousands of years. They're all built using an ancient family of mathematically perfect shapes that unlock some serious power and efficiency. So let's dive into this. These shapes are part of a family called conic sections, and the name is actually super simple. You get these shapes by literally slicing through a cone. Seriously, if you slice it at one angle, you get an ellipse. If you slice it parallel to the side, you get a parabola. It's that elegant. For now, we're going to focus on two of the big players from that family, the parabola and the ellipse. They might look simple, but trust me, they're the secret blueprint for so much of our world. All right, let's kick things off with our first shape, the parabola. And to really get what makes it so special, we're going right back to that satellite dish. So what's the magic trick here? How does this simple-looking dish do something so incredibly difficult? Well, the secret isn't what it's made of. It's the shape itself. It's all about the geometry. This right here, this is the parabola's superpower. Just look at how any signal that comes in and hits that curve, it doesn't matter where it hits, it gets bounced directly to one single tiny point. It's like a perfect funnel for energy. And that special spot where everything meets, that's called the focus. And here's the official rule behind the magic. A parabola is just a collection of points that are all perfectly balanced. Every single point on that curve is the exact same distance from that central focus point as it is from a straight line behind it. It's this perfect geometric balance that gives it that incredible focusing power. And here it is, the actual code. This little equation is the recipe for every single parabola in the universe. If you want to change the shape, you just tweak that little a value, and that moves the focus. And this isn't just for satellite dishes. It's the same code used for solar cookers that can boil water with sunlight, and even for the powerful arches that hold up some of our biggest bridges. Okay, on to our next shape. Meet the ellipse. Now, if the parabola's superpower is all about focusing energy into one spot, the ellipse's superpower is all about distributing it perfectly. And that's what makes it the go-to shape for building things that are incredibly strong and stable. So, you'll notice a key difference right away. An ellipse doesn't have one special point, it has two of them. We call them the foci. If you take any point on that curve, the distance to one focus plus the distance to the other focus always adds up to the exact same number. And that two-point system, that's the secret to its amazing strength. This really breaks it down, doesn't it? One focus makes the parabola an amazing collector. It gathers everything up. But two foci make the ellipse an amazing distributor of force. That's why so many bridges use elliptical arches, and it's also why planets travel in elliptical orbits. It's a shape of perfect balance and stability. So we've seen what these shapes can do, from listening to the cosmos to holding up a highway. Now, let's peek behind the curtain and look at the beautiful, simple math that acts as the blueprint. Think of it as our decoder ring for all this stuff. So this is basically our cheat sheet, and look at how elegant these formulas are. They capture the whole story of each shape. For the parabola, that simple y squared equals 4ax is all you need to describe that perfect focus. For the ellipse, that x squared over a squared plus y squared over b squared equals 1 describes that constant, balanced relationship between its two foci. These aren't just random letters and numbers, they're recipes for building amazing things. You know, once you see this hidden code, you can't unsee it. You start seeing these shapes absolutely everywhere. It really changes the way you look at the world around you, from a simple bowl in your kitchen to the massive bridges you drive across every day.
So here's the big takeaway. The universe seems to have these incredibly elegant, perfect solutions to big problems, like how to focus energy or how to distribute weight. And those solutions are described by these ancient, simple shapes. Math isn't just abstract, it's a blueprint. And these shapes, they're like nature's cheat codes for strength and efficiency, and we're still using them to solve our biggest engineering challenges today.
And that kind of leaves us with one final thought, a question to chew on. We've seen how nature solves the problem of focus with a parabola and the problem of stability with an ellipse. So, what other solutions, what other hidden codes are just waiting for us to discover them, hiding in the shapes we see every single day? Thanks for joining me.